Hello, my name's Robert Lawrenson and welcome to this demonstration video of Navacal. Some of you may have seen my previous video on the initial release of the program under its previous name, which was Scantling and Stability. After some third-party testing and reviews, decided to change it into a web app and have changed the name of it to Navacal as well. The program's very much the same as what Scantling and Stability was, but I've added BV NR 600 compliance for the scantling calculations and also the welding calculations. So it can now do ISO standards for boats up to 24 meters hull length and BV standards for vessels up to 90 meters. So it opens up the calculator to larger vessels. So when you first go to navacal.com, this is what you'll see, which is the home page of the calculator. So if you go to log in and sign up, you can either, if you've already signed up, you can log in here. If not, you can sign up using this button here, which takes you to the Stripe page for payment. This is the test page at the moment. Obviously it'll be live once it's released later today. So the two payment plans are £50 a month or a discounted £500 a year. So if you click start free trial on either of these, it'll take you through to the Stripe payment page, where you just fill out all your details and then click start trial. And then once the trial is started, you can go into the account management section that I'll show you once the calculator is open, and you can cancel the trial but still keep the 7 days if you want, or if you leave it running, then it'll take the first payment on after the 7 days are up. And if you just push it back out of there, you'll get the subscription cancelled. Okay, that's the program now logged in, and this is the main screen you'll see for Navacal when you first log in. So we'll run through the various menus. As I say, the menus are very similar to Scantling and Stability as it was before, but there's a few additions. So if you go into File, you can either save, which saves a JSON with the Scantling calculations, all the inputs in all these various tabs, or save as if you're wanting to create a new JSON file for all the Scantling details. And then if you push load, this will give you a list of the JSON files you've created within the Scantling calculator part of the program. So I'll just load this 7 meter aluminium JSON that you can see here. I've forgotten to save it with the type of craft saved into the file, but as you can see, it just repopulates everything that's been saved before. And then to jump on a bit, if you look up here, we've got ISO 12215-5, but if we click that and change to the BV NR 600 standard, and the inputs down here will change. Obviously the file I've saved was in ISO 1 rather than BV, but one thing you can do is you can fill out all the details in the ISO calculator, save the JSON file, then change to BV and fill out the extra information that it requires for the BV calculations, and then you can run just using this switch between the two standards. You can then go and run the calculations with both standards and produce a PDF report and basically have the same calculation done for the same vessel with both standards. Moving on from there, if we go into the editor's menu, so we've got edit materials, edit stiffeners and edit adhesives. The materials, it's pre-populated with a list of default materials. All of these can be edited, or you can add new materials. So if we click the add material button, it's the same for all the different material types. So you can call it a name, whatever you like. Fill in all these details and then put the material type as one of these, so it's picked up by the correct part of the program. And then we've got, so that's main materials, we've got resins, reinforcements, and then core materials as well. We go into the stiffeners editor. So these are the stiffeners that I've defined for this project and for a couple of the projects that I've been working on. So you can have the same stiffeners file but have various materials within it. So I've got composite cord stiffeners for composite design I was testing the program with, saved in along with aluminium materials for the 7 meter design that I just opened. Just to run quickly through how to add a stiffener. So you call it a name, again whatever you want. Pick from one of these section types. If you want it to be a composite cord stiffener, you have to use flat bar, which is obviously a rectangular shape, and then you choose down here that you want it to be a composite cord stiffener, and that then you put in the base material height and width, and then that then opens up all these fiberglass inputs here. So you click core material, which pulls a list from the wood and core materials parts of the materials file. So if you wanted to add something else in here, you can go into the materials editor and either add a core material or a wood material, and that would populate into this list. And then we just have the fiberglass inputs after that. So fiberglass layers around the core, single layer thickness, fiber volume fraction, and the resin type and reinforcement type also come from the materials JSON. And then you've got the fixing method after that. The only other thing to mention, for some of the stiffener profiles, you can add lightning holes. So you click that checkbox and it opens up the whole width and height within the stiffener, the number of holes, and if it's a series of holes along a stiffener throughout the vessel, like a longitudinal girder with several lightning holes, you can put in, say, 6 holes, and then say they're 600 mil apart. Otherwise, just leave it at 1. And we go into this shared resources. There's a new thing that wasn't in the scantling and stability program, but if we open this up, so what we can do here is download project resources. So if you click the download zip archive, it downloads a copy of all the JSON files stored within that project. And the upload one, so you can either upload the zip that's been downloaded with this button, or you can extract the zip file and upload individual JSON files from within it. And then the file browser, so if we look in here, it's just a list of all the JSON files, and this GLTF is the step file for the stability calculator. That's what it converts into. So when you upload a STP file to the stability calculator, it automatically converts it into GLB files within this GLTF folder, and it automatically deletes the STP file once the GLTF folder has been created. So for all the calculators, stability, propeller, whichever one, if you want to reset all the results within that calculator, take away all the calculation history, you just go into this project resources file browser and then click delete, and that will remove all the history from that calculator and reset it back to a blank slate. Seeing as we have this 7-meter aluminium JSON loaded, so if we look down through the various panels and then the stiffener groups, so the stiffeners, as we just saw, get added in the stiffeners editor, and then for each panel we have stiffener groups. So if we open up adding a new stiffener group, call the group a name, and for each panel, for bottom, deck, side, etc., the orientations are specific to the panel, and then whether the structural role of the stiffener is secondary or primary or natural. Natural would be something like a hard chine welded onto an aluminium hull or something similar to that. Then the stiffener type comes from the stiffener's JSON. So you just choose whichever one you've picked, and then you put the number of stiffeners on that panel, or of this type of stiffener on that panel, in the spacing. And then unsupported length, the angle to the panel that it's fixed to, and the end connection of the stiffener. And that's the same for all these different panels up here. The only thing that changes is in this list up here is if it's a mono hull or multi-hull. But this is a mono hull. It just adds another tab with the wet deck structure. So if we go now to the results tab, all of these tabs are obviously filled out with the panel details and stiffener groups. We can either leave this checked or uncheck it to apply the Lloyd's deflection limit. I'll leave it checked so we can see that in the calculation, and just push calculate, and produces a detailed report by panel. So this is the bottom panel with all the pressures, the actual thickness minimum required, and the margin, and then the deflection that comes from the unsupported span between the stiffeners. Got the deflection check down here as well. Panel curvature, and then we've got each stiffener with its own individual section, with the section modulus, web area shear buckling checks, and web slenderness checks. And that goes on the same for each individual panel. And then the transom, if we have a look in the transom, if we have an outboard or outdrive or jet drive chosen, then we have the we have the engine load calculations. There they are. So it's a composite section analysis of the transom section and whether it can support the power being produced by the engine, or engines if you choose more than one. And then down at the bottom we have for the ISO calculations, we have the longitudinal strength. So if we switch over to a BV calculation, which is a multi-hull vessel as well. And if you look up here, when I push load, it'll change the calculation standard to BV. So this is the superstructure panel. If we go down to the general page, you can see I'll put a couple of test numbers in here just forgot to fill it out when I was saving it. And then the wet deck structure that I mentioned earlier. So we've got the main deck dimensions and then the plating thickness. So what we'll do is, I know this design will fail with the bottom plating being 4 mil, so we'll change it to 8 before we run the calculations, and then push calculate. It's probably still failing on that bottom deck, but we'll see that when we get down. So as you can see here, I've got all the same panel details, but the BV calculations rather than ISO ones. And then the stiffener calculations. And then the transom has got the engine loads as well, but the BV calculation obviously rather than the ISO one. That's the bulkhead that's failing. So the actual is 3 mil and the minimum required is 4 mil. So if I go into the bulkheads panel and change that to a 4 mil 5083 panel, as you can see there, that changes to a pass. And the wet deck structure actually did pass by 0.2 of a millimeter when I changed it to 8. And the superstructure panel as well, I've got it down as 3 mil and the minimum required is 4. One thing to note here for both ISO and BV calculations, when you go and do a fiberglass calculation, so if we change the main material type to fiberglass composite, and in each individual panel you then get the fiberglass layup options, so single skin or sandwich, resin type, reinforcement type, fiber volume fraction, the outer skin layers, single layer thickness, etc. And then when you go into the results section, once you've done that fiberglass calculation, it shows the actual layout here. So it'll show for a sandwich panel, for instance, that you've got 5 mil on the outer layers, 4 mil on the inner layers, and whatever your core thickness is, and then the total thickness will be there as well. And then it does wrinkling checks, shear checks, etc. on the fiberglass panels. And if you look here for the BV calculation, as the wrinkling checks aren't part of the BV NR600 standard, there's a checkbox to apply the ISO wrinkling checks to composite panels if you want to add that into the BV calculation. And then down at the bottom of the BV calculations, we have either global loads for monohulls or multi-hull global loads, because this is a multi-hull with all that information there as well. So I change this back to aluminium 5083 and I'll change it to a monohull and push calculate. We also get the longitudinal strength there as well, instead of just the global loads and torsional shear checks that's on the multi-hulls. So if we now have a quick look at the stability calculator, I've already got a 3D model loaded in there, as you saw earlier on the file browser in the GLTF folder. So if we open this up, we'll see it's a 7-meter boat design that I've been working on. So to run through this quickly, this recalculate button, or we'll start at the top. So you choose whether it's a monohull or a multi-hull, which changes how the waterline calculation works. The windage area, so once you've assigned materials, which this boat is 1.4 tons, it's actually not correct. I just assigned the same material, which was 5mm 5083 aluminium to every part, so it's just to get the waterline shown. Then you push calculate, and then this windage area is a side view of the windage area above the waterline. It's also user editable if it's incorrect as well. And then the windage height above the waterline you enter manually. The downflooding point, which is represented here by the black dot. So if we put that like that, you can move it just by clicking down, pick downflooding point. And then recess parts, so for scuppers or any other recesses, what to do is when you're in the 3D design program, whichever one you're using, whether it be Rhino or SolidWorks or whatever, if there's recesses, say here, make them surfaces, assign them to their own layer in the layers panel within that program, and then when the STP file is loaded into this calculator, you would basically hide everything, show your recess parts. Let's say it was the gunnel brackets in this instance. Click select visible, and then select recess parts, and then those parts would be selected as the recesses. So we'll go show all again, and then select visible, and that's all the parts selected on this boat. So you then move on to assigning materials. So you can either use fiberglass, single skin, or sandwich, which then opens up the same fiberglass options that you would see in any other panel. And then once the details are filled out, you click assign to selected, and the program works out the weight of the fiberglass material and applies that to the layers selected. Or we can just use so if we use one of these steel ones, because this boat's aluminium just now, steel, just assign 5mm to everything and click assign to selected, and as you can see, the boat's then jumped up to 4 tons, and the water line's gone way up the side of the hull. The other thing you have to do before assigning materials to it, though, is assign the outer hull surfaces, so anything that's going to be touching the water. Something else to note is in the 3D design program you're designing the boat in, before exporting it as an STP, try to ensure that the surface normals are all pointing outward. I have built a function into the program to check this, but just to be certain, it's better to set the surface normals before exporting the STP file. another thing to note about the STP file to make sure the layers work is it has to be in either AP214 or AP242 file type. The older file types don't transfer the layers correctly, so if it's either one of those two formats, then it'll work fine. And as you can see, the windage area is dropped because of the water line going up to an unrealistic height. We'll put it back to aluminium, and then water line will update. If we look at the calculations page, so you've got the ISO part, so part 1 non-sailing over 6 meters, part 2 sailing over 6 meters, and part 3 everything under 6 meters. Design category, and then assessment option, so these change depending on ISO part chosen. And all the inputs change as well depending on, so if you choose, for instance, the part 2 sailing calculations with it comes with a lot of extra inputs. A lot of them are filled out automatically from the 3D model, but a lot of them you have to enter manually. So if we go back to the part 1, as you can see here, we've got all these inputs that are automatically filled. The crew area beam, it works it out at 85% of the overall width, but if you want to set that manually, if it's got wide side decks, etc., then you can set that. The crew limits, sealed buoyancy, volume, bilge pump capacity, propulsion type, and then we've got the centre of gravity, centre of buoyancy, and centre of flotation, which are all automatically calculated. And then right down at the bottom we've got the option to add point weights for fuel tanks, people, gear, whatever, and all the calculations above plus the water line all update as the point weights are added. And once all this page is filled out, depending on which calculation you've chosen, you push perform selected assessment, which initially calculates the GZ curve and then performs the selected assessment that you've chosen. And then that then appears in the results page. And you can export single calculations, or you can export multiple as PDF or Excel format once you're complete. And then finally in the stability calculator we have the bill of materials. So you can include material wastage, set a percentage, choose currency, and then set material costs per kilogram. And then generate a BOM. It does it automatically in US dollars at $4.50 per kilogram, but you can change all that and then push the generate button, and this will repopulate after that. Okay, we close this and go out of that. We'll have a quick look in the manage subscription menu that I mentioned earlier on. So if we open that up, you can see it's obviously in test mode, and I chose the £500 a year subscription option, and I've gone past the free trial part of it, but you can either update the subscription, so move from monthly to yearly or yearly to monthly, or you can cancel the subscription. Something else that pops up if you're on the trial is there's a button to end the trial early and move to a paid subscription. So as part of the trial subscription, I've got it set at a limit of 3 projects and 7 days. But if you're happy with the program and you want to move to the paid subscription early, if you were in the trial stage, there would be a page that would come up before this one saying, do you want to end the free trial early? Now if we can go and have a look at the rest of the calculators in the program. So the beam calculator, you can call it a calculation name. It's user editable. And then you've got the various beam types that you can calculate here. If you leave it as stiffener, and then that gives you the option to use all the stiffeners from the stiffeners JSON that you've created in the stiffeners editor. And then you can calculate that as a beam. So if we change that to, say, a landing boom, all the inputs then change. The point load, distributed load, and then all the section dimensions and how it's supported. And then you just click calculate. And then it gives you an output showing whether it will pass or fail depending on the inputs you've entered. The welding calculator, so again, for the ISO version, so we've got ISO and BV here. So if we start looking at the ISO one, it asks for item to be welded, which gives you a list of all the stiffeners in the stiffeners JSON, or you can click custom to create a custom welding plan for anything else. You click panel to be welded to, and then panel thickness of the panel you're going to weld it to, the span, which is the unsupported span for the welded stiffener, and then the type of joint. And welding type is continuous single or double fillet, intermittent double or staggered intermittent fillet. And then the stiffener spacing, design pressure, which you get from running the scantling calculations, and then the safety factor, and then you just click calculate, and then it gives you a welding plan for whichever material you're working with. The BV calculator, so you got the connection type, which is the various connection types within the BV standard, and the rest of it is much the same, apart from the calculations in the background are obviously the BV calculations rather than the ISO ones. And again, just click calculate, and in the calculation history it's quite easy to see here which ones are done with BV and which ones with ISO. Structural details calculator, so got 3 tabs here, so whichever tab you've chosen is the one that will be calculated. So you've got the engine foundation calculation, which again pulls its stiffeners from the stiffeners JSON. Pillars, so if you add a pillar, you can choose either ISO or BV again. Put in the location, the load type on the pillar, and then the material is solid materials or the main materials from the materials JSON as well. And openings, so for a hatch or some sort of opening in the deck, so you pick the plate material that the panel with the opening in it is made from, the panel type, so bottom, side, deck, etc. And then the stiffener type, which again comes from the stiffener JSON. And then just push calculate. And again, the results will appear here and the history. Sale calculator, so You fill out all of these different tabs and then calculate the whole sail and mast structure as a whole. So you've got the environmental conditions first, sail analysis, so various sail types, rig types and reefing systems, and then sail dimensions and sail material properties. You've got some stability inputs to enter on this part. Mast and rigging, so you've got the mast material type, which again from the materials JSON, so it's all user editable. The mast height, the mast section, so we've got 4 mast types here, so if we select teardrop for instance, then the inputs change depending on mast type. And then rig geometry, so you've got the forestay and backstay, base offset, and once all this is completed, once every part of the tabs are filled out, then you just push calculate and it will calculate each section and then the mast, sail and rigging as a whole also. Rudder calculator, so again within the rudder calculations we've got ISO 12215-8 or BV NR 467 Part B calculation options for the rudder. Various rudder types that can be chosen. Design category for the ISO calculation, and then you've got the navigation notation, profile type and propeller position that appear when you choose BV. So we go back to ISO, we've got the stock material, so you choose that from the metal materials in the materials JSON, the vessel parameters, the rudder overall dimensions, and then the blade structure designer. So for ISO and BV, what's down here is pretty much the same. So you can either have the rudder blade made of the same material as the stock material, so you just fill it out and leave that as it is, or you can select from a different metal an FRP sandwich, so that's a hybrid metal skeleton with a fiberglass outside, or a fiberglass sandwich, which is fiberglass with a core. So when you click the FRP with core, or the sandwich with core I should say, the fiberglass options appear up here, and the same if you click hybrid. So, and then for the stiffeners, both vertical and horizontal, you choose them from the stiffeners JSON. So you put the spacing in for the vertical stiffeners, and then the number of horizontal stiffeners, and the program works out internally the unsupported span between the stiffeners from that information. And the keel, it's only an ISO calculator, but it's very much the same as the rudder calculator. We've got different load cases down the bottom. You can enable vertical and horizontal stiffeners, which pull from stiffeners JSON. In material type, so the attachment methods, if we look here first, so we've got molded, bolted on, welded, bonded, or a stub keel with bolts. In material type, so we can either go with metal, hybrid again, or sandwich, which again opens up the various different options to calculate both of those. And then finally we've got the propeller calculator. So this uses the Holtrop meaning method for the displacement calculations and Savitsky analysis for planing boat calculations. So I've tested it on a few known designs that I have, and it's pretty accurate, to be quite honest. I know propeller calculators or certainly ones I've used in the past haven't been the most accurate, but I've spent a lot of time on this and quite confident that it's quite an accurate propeller calculator, and I'm quite happy with how it's come out. Okay, if you have any questions about any of these calculators, please feel free to get in touch on the info@navacal.com email address. But please sign up and have a try of the program. The 7-day free trial is there. I can also extend the 7 days if you need more time to go through the various functions in the program, and if you have any questions about it, please let me know. Okay, thanks very much for watching.